Hey you guys, today we're starting chapter 8. This is about similar polygons, perimeter and area. It's a lot. In class we might have to split it up in 2 days, but I'm going to give all the notes just right now. I want you to go back and remember when we talked about congruent polygons, and I'm going to stick to triangles just to keep it simple. If two triangles were congruent, that meant the corresponding parts were congruent. And when we say parts, we're talking about angles and the sides, okay? So if this triangle is A, B, C, this triangle is D, E, F, all the sides have to be matching, corresponding sides have to be congruent. So if this is 6 long, this would have to be 6 long. If this is 8, this would have to be 8. This would have to be 10, right? They're identical copies. I could cut this one out, lay it on top of that. And that is called congruent. It just means they're the same. It also means that the angles have to be exactly the same measurements. So if this angle is 37 degrees, this angle is 37. If this angle is 90, this one's 90. If this one's 53, right, that one's 53. All the corresponding parts are congruent. And we would write this congruent, we would say triangle ABC is congruent to. And when we match it up, the A has to match up with the D. B has to match up with the E. You guys get where I'm going? So the two triangles, the congruence statement would be this, which then meant angle A and D, those are corresponding parts. Angle B has to match with angle E. And then angle C has to match with angle F. This is what you learned before, okay? We also said all the segments. AB, side or segment AB would have to be congruent to segment DE. Side BC, last two letters, side EF. These two segments have to be congruent. And then lastly, A to C and D to F, the hypotenuse. Okay? We learned this earlier. What we're going to do today, instead of talking about two being congruent, the whole lesson is based around two polygons that are similar. Now, similar means I could take one and enlarge or reduce it, but it's supposed to be exactly the same. So if this angle down here, let's see, what's this one look like? About 88 degrees, then this would have to be 88 degrees. You guys with me? They're going to be the same shape, exactly the same shape, okay? Let's say this is what, 40? And this is 40. So it's 128, right? 180 minus that. Okay, so it's 52. So this angle would be 52 and 52. So the corresponding angles are all going to be exactly the same. The angles that match, that correspond, are going to be the same. But the size is it doesn't have to be different, but it can and most likely will be different. So if this one is 2 and this one is 6, this one on the right is 3 times as big. And they would, if it's going to be similar, that means all the sides would have to be like this. So if this is 5, this would have to be 5 times 3 is 15. If this side here is 6, then 6 times 3 is 18. Okay? All the sides, so the sides have to have the same ratio, and the angles are the same. Now I'm going to go through this slow, but this is what we're doing today. We're going in first semester, we talked about congruent triangles. This semester, this chapter, we're going to do similar polygons, but I'm talking a lot about triangles. Okay, so let's get our notes and start filling in stuff. We're going to start with words that you're going to need to know. I'll give you a few minutes, walk around the room, and when you're in class, they're going to do it that way and help each other figure this out. But for us now, we're just going to fill it in. Perimeter, circle the word rim. Okay, the rim. So it's like the rim around a shape. It's the sum of the lengths of the sides of a polygon. Okay, it's the fence, right? It's the fence around something. Length, length, width, width. Perimeter equals the length plus the length plus the width plus the width. Okay, that's all that perimeter is. Something that you guys have done a lot. Okay, perimeter. Area is the number of square units within a polygon. Okay, these are two-dimensional. So this would be like the grass inside the yard. This is the fence. This one here would be the grass. Okay? So if I do this, I'm talking about the square units. Okay? How many squares fit within the rectangle and area, just in general, as length times width. Okay. Congruent polygons. On this one, I want to say they're the same size and shape. Exactly the same. They're mirror images. I could cut one out and lay it on top of the other. Corresponding angles are congruent. And number 2, corresponding sides are congruent. Okay? That's what we did before Christmas. We did that side, angle, side. Remember all these? Side, side, side. We did all those theorems. Okay? Remember, this time, it's nice to remember what congruent is to help us remember what similar is. Okay, a ratio is just a comparison to numbers. Okay, so I could write like 2 to 3 as a with a colon. I could put 2, 2, 3, or I could write 2 to 3 as a fraction. We're going to do mostly this. This is just easier for what we're doing. I think of a fraction. Okay? Now a proportion, that's when you're setting two ratios equal to each other. Okay, two fractions are equal. So if I say 5 is to 10, as 8 is to, good, 5 is to 10, as 8 is to, this would have to be 16. And that's what we're going to work on. We're going to use solving proportions to do a lot of our work. If you guys remember when we're solving proportions, the top times the bottom. Some of you guys in middle school called this the butterfly method. Proportions are really cool Because you could go 5 times 16. Well, I'm not going to go through all of it. Equals 8 times 10. Oops. Times 10. Okay. Just 5 times 16, 8. We're going to use this a lot. Now, a scale factor is a specific type of ratio. We said a ratio just compares two numbers. A scale factor is a ratio with a specific purpose. Okay? So I'm going to put just regular words. It's a ratio that shows how much a shape is made smaller. So we're going to say reduced. Sorry. Or if it's made bigger, enlarged. Now, when we talk specifically about a scale factor, which we're going to do in a little bit here, okay? It's a ratio between corresponding sides. I mean, a ratio that shows how much a shape is reduced or enlarged. Okay, let's go back to this. So on this one, I went from 2 to 6. I went 2 times 3 to get to 6. 2 to 6 is a ratio. It's also called a scale factor, okay, because it's showing me that this shape is 3 times as big. I went from 2 to a 6. I went from this to this shape. Exactly the same shape. Angles, corresponding angles are congruent, and the scale factor between them is 2 to 6. It's 1 to 3. This is 3 times as big. So a scale factor shows how much larger a shape is than the first one or how much smaller it is compared to the original. Okay, it's a ratio between corresponding sides of similar polygons. So really, this word might be new, but hopefully the other words, well, let me circle all of them. Kind of got messy, didn't it? Sorry about that. Okay, those are our words. Vocab. Now, if two shapes are similar, right? So we're going to write this down. Like in generic words. This isn't like a math official. It means they have the same exact shape, okay, but may be different size. I'll put different sizes. Okay. Here's your two things that have to be true. The corresponding, which means matching, right? If you need to write matching, write matching. If you don't, don't. Corresponding angles are congruent. The angles that match up have to be the same. And then the corresponding sides are proportional. So, when they're proportional, that means that scale factor between the two shapes is the same for all the sides. Okay, go back to this. We're going to write this down. And here's what it means. This one, I'm going 1 to 3. 1 to 3. I have to multiply this by 3 to get this. 5 to 15. See, 2 to 6, that's one comparison. These are corresponding sides. 5 to 15. Corresponding sides. 6 to 18. corresponding sides. All of these equal the same thing. If you reduce all of them, they equal 1 to 3. That's their scale factor. Okay? That's what this means. But we're going to do this. We're going to write it, but I'm just telling you that's where we're going. So the ratios of corresponding sides of all the corresponding sides are equal. Okay, let's draw some triangles here. Let's draw a right triangle here. And let's draw one a little bit bigger. Okay. We'll call this triangle A, B, C, triangle D, E, F. I'm going to tell you right now that triangle A, B, C is similar, okay? When we say they're exactly the same, we use congruent. That means they're exactly the same shape and same size. Now we're saying they're similar. They have the same shape, but the sizes are different. So A, B, C, I have to match it up. D, E, F. Okay? When I do that, that means angle A is congruent to, what's A match up with? First letter, D. It means angle B is congruent to angle E. And it means angle C is congruent to angle F. Here's the hard part though. So all the corresponding angles are congruent. Now I'm going to say the corresponding sides are proportional. So if I'm going to go AB, so AB has to match up with DE. AB and DE are sides that are corresponding. So AB is to length DE, as BC is to length EF, which is the same thing as AC is to DF. Okay, that's a lot right there. Let's try a couple problems first to see where we are. Okay? Before we do anything like hard with geometry, we're going to review a little algebra. So I'd like you to go to the bottom of the page, and I've got 3 algebra problems. And on this it says solve each proportion. Remember, this is a ratio. X plus 2 over 3 is a ratio. 2 over 5 is a ratio. When I set 2 ratios equal to each other, we call that a proportion. When I want to solve proportions, I set their cross products equal. I have to have an equal sign in this. I'm going to set the cross products equal. I'm going to put if I put x plus 2 first and the 5 after, it's kind of confusing. It's 5 times all of this, so I'm going to put the 5 in front, and then 3 times 2. Go ahead and do your distributive property. 5 times 2 is 10. I want to isolate the x. I always get rid of whatever is on the same side with the x. I want the x isolated. And then divide both sides by 5 because you want the x isolated. Okay? You guys try 2 and 3. You will use this algebra to solve the proportions that we're going to do on the other side. Okay? So now what we're going to do, let's look at some of these. I'm telling you that this shape, G, H, J, K, whatever that quadrilateral looks like, it is similar to this quadrilateral. So GH, which is the first two letters, is to LM. GH is to LM, as JK, my second two, is to my second two. So that's what you're filling in. So on this, you're looking at patterns. That's all you're doing. Okay? I'm going to get a different color because I should have done it in pencil and I didn't. Let's do, on this one, LP, right? So L is to P, L is to P. See where I'm going? L is to P. And then they're going MN. So we're starting on the, this is my right, and then right is on top, right? MN. And then HJ is the left one. So if you're going from right to left, you have to go from right to left. You have to keep that same pattern. So MN is the middle two letters, is to HJ, middle two. And then I'm going LP on the right to GK. Look at the patterns. Okay, we're going to come back to 6. Okay, let's go back. On this one down here, though, I think we could do some of these. It says, the polygons are similar. Find the value of x. So they're saying this angle, one curve to one curve. I've got two curves to two curves. And I got three curves to three curves. So they're telling me which angles are corresponding angles. So this one's pretty easy, so I can look at the sides. I have to find out what x is. That's my job right now. I could see the ratio of these two sides is 21/14. Now, I think it's easier to reduce that. You could use 21/14, or you could use 18/12. Notice on both of these, I'm going from the right to the left, right to left. Okay, I'm going to go ahead and use the 21/14 ratio. Again, if you divide both of these by 7, you can reduce it to 3/2, which makes the work easier. I'm not going to do that because I know a lot of you won't. Okay, so I'm going to go 21:14. Uh-oh, I said right to left, you guys. 20 and 14, this is left to right. Good gracious, left to right. Okay, I'm going left to right. 21:14 as, now I want to match this x up with the side that it goes with, and that's 20. So 21:14 as x is to 20. And then my numbers again are going to be kind of big because I did not reduce them. So we're going to go multiply 21 times 20 equals, this equal sign is super important. It's not a fraction. I'm writing an equation. 21 times 20 equals 14 times x. Okay? So 21 times 2, 42, 14x, and then divide by 14. Okay? That's how you solve these. And these are laid out. This one is a flip, right? So pay attention to this because this is a flip of each other. This one's just sliding right over. So that one's not hard. Okay. On these 12 to 15, okay, I'm not talked yet about area and perimeter. So KLMN, that polygon is similar to QP. Wait. What did they do? KLMN. QP. Oh, yeah. PQRS. We got to fix that, baby. I took this out of the book. Okay, I'm going to come back to this. I'm going to have to fix that. Okay, flip it back over. We're going to go into some hard stuff. Okay, if this shape is similar to this shape, then the perimeters, okay, here, let's write it. If two polygons are similar, then the ratio of the perimeters equals the ratio of corresponding sides. This is kind of cool. That's all it is. So if this is a 2-to-3 ratio, then that means the perimeters is a 2-to-3 ratio. If this is a 1-to-5 ratio, that means the perimeters is a 1-to-5 ratio. Okay, so we're going to write this. If they're similar, then the perimeter of KLMN over the perimeter of PQRS is just equal to the scale factor between these. I'm just going to say the length of KN to the length of PS. You can pick any two sides. So the scale factor, that's all it is. Okay, this one, if two polygons are similar, this one's kind of weird. It's cool though. Then the ratio of the areas, the fraction comparing the areas. Remember, area is a square unit, right? It's how many squares are inside here, right? That's areas. If I'm going to compare this area to this area, then I'm going to square the scale factor between them, okay? So it equals the square, you have to square it, now I'll remind you that, of the ratio of corresponding sides. Meaning, take the scale factor and square it. When I say square, I'm talking take that number, square it, okay? So like if I say 5, 5 squared means 5 times 5, which is 25. When I'm saying squared, that's what I'm talking about. We're going to square it. So if the scale factor is 2-to-3, okay, then we're squaring it. We're squaring both of those numbers, so it'd be 4-to-9. That's what we mean by squaring it, okay? So the area of KLMN over the area of PQRS is equal to, you're going to compare two sides that match up. I'm just picking these two. Take two sides, and I'm going to square the sides. And then you could solve it. Okay. This is a lot. I know it's a lot. We'll practice. The scale factor between the sides is A to B. So the scale factor for the perimeters equals A to B. But the scale factor of the areas, because area is squared, right, is A squared to B squared. Okay, we'll practice more in class. This gets you started, okay? Let's do this one up here, though, real quick, okay? I've got GHJK. So it doesn't say what kind of shape it is. I'm just going to draw something. G, H, J, K. Okay? Is similar to, and I'm starting here with G, so I have to match it up. L, and I went G to H to J to K. I'm going down and around. So I'm going to go L, M, N, P. Okay? Now it says from G to H is 7, and from L to M is 12. I know that these are corresponding sides because of my similarity statement. It's written so that the corresponding sides match up. So what is the scale factor from GHJK to LMNP? And the scale factor is that ratio of corresponding sides. So it's 7 to 12. If I knew all these sides, and I could add all of the sides together and all of these sides together, what's the ratio of the perimeters? It's still going to equal 7 to 12. Okay? What is the ratio of the areas? Now, because it's area, it's going to be 7 squared to 12 squared. That's the ratio of the areas. If I take the area of the left to the area of the right, it's going to equal 49 to 144. Now it says find the perimeter. Okay, so I know the ratio of the perimeters is 7 to 12. It says the perimeter of G, H, J, K, this perimeter equals 98. If I add all these sides together, the perimeter is 98. So when I go 7 is to 12, as the perimeter of this is to the perimeter of this. Okay? Equals 98 to x. And then you do the cross products and solve it. Find the area. So this time, okay, you're going to go 7 is to 12. But our, right, we said we have to square it. You with me? So now you have to find the area of this one. What do you guys think? We have to know the area of one of them. Can we go back real quick and do this? If this is 7, well, I'm going to let you guys think. Okay, so that's where we're at, but this is how you do it. And I'm going to look at this problem again. We might have to make some corrections. So before you guys do that one, look in class. This one, oh, I love these. Always, sometimes, never. Look at those and think, okay? I hope this helps you guys. Please let me know if you have questions. Talk to you later. Bye.